Here's a diagram of an atom. It's not perfectly accurate, but for what we need right now, it's going to do just fine. So in this lesson, we're going to look at characteristics that we can use to describe atoms like this one. You know, if somebody asked you to describe a person, chances are you'd use characteristics like the color of their hair, the color of their eyes, what their height is, and so forth. Just like that, there are characteristics we can use to describe atoms. The first of these characteristics, and maybe the most important, is the atomic number. The atomic number is often abbreviated by a capital letter Z. And what the atomic number is it's the number of protons in the nucleus of an atom. In my diagram here, I'm using these red circles to represent protons. So I have 1, 2, 3 protons in this atom. So the atomic number is going to be 3 for this atom here. Atomic number is particularly important because the number of protons in an atom tell us what kind of an atom it is. And by that I mean, is it a carbon atom? Is it an oxygen atom? Is it a sodium atom? We're going to talk more about that in the video on isotopes, so you don't have to worry about it for right now. The next important characteristic that we can use when describing atoms is the mass number, often abbreviated by an uppercase A here. Mass number is the number of protons plus the number of neutrons in the nucleus of an atom. People always get confused by mass number. Here's why. Atomic number is the number of protons. So everybody always wants mass number to be the number of neutrons. But it's not. It's the number of protons and neutrons. In fact, there's not really a name for the number of neutrons, just the number of neutrons in an atom. We just don't use it that often. So anyway, for mass number, we want to count all of these together. 1, 2, 3, 4, 5, 6, 7. The mass number of our atom here is going to be 7. Now finally, the third characteristic we're going to talk about here is probably the most complex, and that's called net charge. I don't have a good way to define net charge. I mean, I don't have a good definition. So what I'm going to say here is it's how protons and electrons balance each other out. Let's talk a little bit more about this. So net charge is about how protons and electrons balance each other out. So protons, as you know, have a positive charge, and electrons have a negative charge. So that means that if we have the same number of protons and electrons in an atom, like I have right here, 3 protons and 3 electrons. I'm not drawing the neutrons here because we're not worried about them. Here we have the same number of protons and electrons. They're going to balance each other out. This 3 minus is going to balance out the 3 positive. So we're going to end up with an atom that has a net charge of 0 because these two things balance out. And we can call this atom neutral, which means that it has no net charge. Now, what would happen in an atom where we have 4 protons and 3 electrons? We don't have the same number of electrons and protons anymore, so they can't totally balance each other out. Instead, we have more protons than electrons, so that we're going to have a net charge that's positive, because there's going to be some of this positive charge in the protons that can't be balanced out by the electrons. In this case, we have 1 more proton than electron. So this is going to give us a net charge of +1. Since our atom has a net charge, we give it a special name. We call it an ion. An ion is any atom that has a net charge. Neutral is what you call it if you don't have a charge. Ion is what you call it if you have any charge. Okay, this is where we have 1 more proton than electron. What about this case here? What if we had 5 protons and 3 electrons? In this case, the charges don't balance out either, but now I have 2 more protons than electrons. I've got 2 more protons that aren't getting balanced out by these electrons. So that means that I'm going to have a net charge of 2+ for these 2 protons. And again, this is going to be an ion because it's got a charge. Now the opposite can happen as well. Here is an example where an atom has 4 electrons and 3 protons. So now it's got more electrons and protons. These 3 protons can only balance out 3 of the electrons, so I have 1 more electron that's not getting balanced out. That means that this total charge is going to be -1. That's a charge of this 1 more electron that I have in the proton. And if I had a case in which I had 5 electrons, oh, and I should have said, we call this an ion, because it has a charge, just like this. Negative charge, positive charge, it doesn't matter. If it's got a charge, we call it an ion. Okay, so anyway, we have a case where we have 5 electrons and 3 protons. Now there are 2 more electrons and protons, so I have 2 negative charges that aren't getting balanced out by the proton, which means that I have a net charge of -2, and this also is an ion. So that's how you can figure out net charge. So what's the net charge for this atom? Well, we have 1, 2, 3, 4 electrons, and we have 1, 2, 3 protons. Since they're different numbers, the protons and electrons aren't going to be balancing each other out. We have 1 more electron than proton, so that means that we have a net negative charge, and since there is 1 more electron than proton, this atom here is going to have a net charge of -1. So now that we've talked about these 3 characteristics you can use to describe an atom, let's look at the practice problem video so that you can go over this in a little bit more depth and try a bunch of examples.